So this is the second video for the Unit 3C chart, and we completed the front page on the first video. So we are on the back. So let's get it in there and focused. Okay, so graphing in intercept form. So on the front we had just completed graphing in standard form. So now we're going to graph in intercept form. All right, so again, what happens on all of these, I don't feel like it's focused. Okay. What happens on all of these is that we need to figure out the location of the vertex. And when we figure out the location of the vertex, then we can check to see how the size of the parabola is and create more points from there. So when we have intercept form, the vertex is going to be located in the middle of the x-intercepts. So if we go over here, if we were to solve this, it's already factored for us. So if we were to solve this, we know that -4 would be one of our roots, or zeros, or intercepts, and +2 would be the other one. So what we need to do now is figure out what is the middle of -4 and +2. So basically what we're doing is the average. So if we were to add these together and divide by 2, then we know that our axis of symmetry is located at -1. So I added those together and divided by 2 because I'm just trying to find the average. So now we know that the vertex is located at -1 something. All right, now that we know what the x is, we just go back up here and fill it in. So if we want to know what y is, we have a 2. All right, we're going to fill in -1. So -1 plus 4 would be 3. And if we fill in -1, -1 minus 2 would be a -3. And if we multiply all of this together, we get -18. So -18. So our vertex is located at -1, -18. All right, now another comment is that when we go over here to this graph, we know that one of the x-intercepts is right here at -4, and the other one is right here at +2. So we know those 2 points are going to be on this graph. So if we look at here is our axis of symmetry. And we found that, that our vertex was at -1, -18. So let's count here. 1, 2, 3, 4, 5, 6, 7. So we could go down by 3s if we wanted to, because that would be 3, 6, 9, 12, 15, 18. So let's say this is -18. Right here. And I have a purple. So we'll say that this is -18. And I know that, normally we number right here, but for space I don't want it to look too confusing for us. Okay, so then we're going to go up here and scope out the value of A. The value of A right here is a 2. So that tells us that this parabola has been stretched 2 times taller. So instead of going over 1 and up 1, we would go over 1 and up 2, which then we have to keep in mind our graph is going by 3s. So we're going to go over 1 and up 2. It would be like that. Normally we'd go over 2 and up 4, but this one's twice as tall, so we need to go up 8. So there's 3, 6, 8. All right. Normally we'd go over 3 and up 9, but we need to go twice as tall, which, wow, imagine that, is 18. So it lands perfectly right there. And then we can use our axis of symmetry to get the more. If we wanted to, we could keep going to scope out where it goes here. So if we went over 4, we would go up 16 normally, but that means we'd have to go up 32. So there's 18, 21, 24, 27, 30, so maybe right around there. If we, just to have a little more of a guide. And then we can connect our points, and there's our parabola. All right, fantastic. Moving on to vertex form. I think this is everybody's favorite. Vertex form actually is the same as transformations, which is what it is at the bottom of the page. So everything from here down is kind of basically the same thing. But what happens in vertex form is that we are going to use the vertex straight from here. So we don't have to average it like we do on intercept form. We don't have to do the negative b over 2a like we do on standard form. We can just look right here, and the vertex is hk. So once we know that, then we'll, again, look at the value of the a to see if it's a normal size or not. Perhaps it's going down instead of up. So we'll make that decision once we get the vertex taken care of. So here is our example problem. So looking right here, our vertex is right here. And again, it's always the opposite of the x. So our vertex is located at 4, 5, which tells us that the axis of symmetry is x equals 4. So let's go ahead and graph that. So over 4, 1, 2, 3, 4, 1, 2, 3, 4, 5, 4, 5. So there's our vertex. Here's our axis of symmetry, which is our mirror image line. So now we know our parabola is going to sit right there. So scope out the a. Here's the a right here. The value of a is -2. So I know you can't talk back to me. I'm not Dora the Explorer, but hopefully you're thinking that this tells us that yes, it's 2 times taller, but it's also upside down. So instead of going over 1 and up 1, we're going to go over 1 and down 2. And then a normal parabola would be 2, 4, but we're going to go 2 and then down 8. I think I got that in the right place. And then we're not going to be able to fit the third one over, but if we could, normally we'd go over 3 and up 9, which means on this one we'd have to go down 18, and we can't. So we'll just use these points. This will work. So that gives us enough of a guide to then graph our parabola. And there we go. So that's graphing in all 3 forms. So no matter what form you do, what you want to do first is get the vertex. Once you know the vertex, you know so much information about the parabola. You know the axis symmetry, you know the starting point. And then that value of a tells you everything else you need to know. Whether it's going up, whether it's going down, if it's normal size, if it's stretched. Maybe we did a shrink instead. Maybe we did half of the size of a normal parabola. So that, I think, is the easiest way to graph any of these. All right, next up are the transformations. And once we learned vertex form, we kind of talked about how vertex form is really just showing the transformations that you learned last year in Math 8 on a graph. So hopefully you remember. I think I'm getting tired of red. I'm moving. Got this army green color. All right, so first up, this one right here, this is part of our vertex, but this is the x value of the vertex. So this tells us whether to move right or left, and remember it's always the opposite. The value of k tells you to go, I don't know why I wrote down first, down or up, but you use k as it is. This value of a right here tells you if there is a stretch or a shrink. And then if it's positive, it goes up. If it's negative, it goes down. So positive opens up, and a negative parabola is going to open down. So when we look at our equation, we get all of this information, which then makes graphing so much easier. Okay, so describe the parabola. All right, so I'm just going to start with the vertex. It doesn't matter. Order's not important. And in fact, I'm just going to do little bullet points. So, you know what? I changed my mind. Let's start at the beginning. So first up, this negative tells us that it is reflected over the x-axis. All right, this 3 tells us that we have stretched 3 times taller than it normally is. This 2 right here in the parentheses tells us that we need to shift left 2. And then this -8 at the end tells us that we are going to shift down 8. And then just to refresh your memory, when we go right and left, that's horizontal. And when we go up and down, that's vertical. So if you see horizontal shift or vertical shift, that's just kind of confirming the direction that you should be moving. All right, next one, describe the parabola. So let's see. Start at the beginning again. 1/3 means that we are going to shrink to 1/3 of the size. All right, so we're not shrinking by 1/3. We had this conversation in class. Hope you remember it. We're not going to shrink by 1/3. We're going to shrink to 1/3. And that is the difference. The only time it's not is if you do half. So if we're shrinking to 1/3 of its size, then we're here. We're going to shrink to 1/3. It's going to be just the tiny, tiny one. All right. There's nothing in the parentheses with the X, so that tells me that we're not shifting horizontally, right or left, but we are going to do a vertical shift. So we need to shift this parabola down 2. All right, so the last part on this chart is just doing all of this together. So what we're doing here is we're going to identify the transformations, and then we're going to do the graphing. So we're going to start with the vertex and then check to see if it's normal size and then make the points from there. All right, so it says to identify the transformations. So first it's stretch 2 times taller. This 3 tells me that we are going to shift left 3. And then the -4 says that we're going to shift down 4. All right, so we also know that when we look at this in vertex form, we know that the vertex right here is going to be -3, -4. And that's our shift left 3 and down 4. So here's our vertex. And then it's going to be stretch 2 times taller. So we have our axis symmetry right here. So we're going to go up 1, over 1, up 2, over 2, and up 8. And I don't think we're going to fit the next one, so that's good enough. So this one was stretched 2 times taller, which makes it a thinner parabola, and there we go. All right, last one, and then we're done, almost finished. Identify the transformations for this parabola and then graph. Okay, so first thing this negative tells me is that we need to reflect over the x-axis. There's no stretch or shrink, so it's a normal size. It's just going to go down instead of up. And then we have a -2 in the parentheses with the x, which tells me that that's going to be a horizontal shift right 2 spaces, and then we're not going up or down any. So if we think about where the vertex is located for this parabola, it's located at 2, 0. So if we plot 2, 0 on our graph, where here's our axis of symmetry, and then it's a normal size, but we need to reflect. So instead of going over 1 and up 1, we're going to go down 1, over 2, down 4, and again, I think that's good enough to get the shape of our parabola. All right, perfect. So that covers converting and graphing for Unit 3.